All right, we're back. At this point, you should understand how a full wave and a half wave works. You should understand why the curve or the waveform changes and what components are responsible for making those change. If you don't, go back and review those videos. We're building on those videos, so it's just going to get more and more complicated as we go along. So you need to have a good understanding of those. We're going to start the bridge rectifier. We're going to construct it and then look at the waveforms just like we did for full wave and for half wave. This, I've already got the components on here just to save time. We're going to use the same AC waveform, 120 volts. Notice that I've changed back to the transformer that we used the first time. We don't have that center post. And I'm going to keep it at a 10-to-1 ratio. And a 10-to-1 ratio at 120 volts should give me a 12 volt peak to peak. And here's the important thing. Now we have 4 diodes, and we have to make sure that the diodes are in the proper orientation. We are going to be flowing the voltage through these diodes, and we know that if the diode is not in the proper orientation, then the current and the voltage will not flow through it. It stops it. So we have to make sure that they're in the right orientation. I have them right now in the correct orientation that you should have them in. Usually these things are kind of on a 45-degree angle. It looks a little bit cooler, but unfortunately this program doesn't allow me to put them at 45 degrees. So we're just going to make a box. Now, how do we have these things hooked up? It's all going to depend on how we hook the rest of the circuit up, which is what we'll do right now. Here's our load, of course. So what I'm going to do is I'm going to hook the load up first. Hopefully you guys have a good understanding on how this program works. That's going to drive me nuts. I got to move that over. Okay. It's pretty easy. I kind of like it actually, and it's free online, which is always good. So that's how you're going to hook your load up first to start with. Notice that this is the cathode side of our diodes, and that goes to one side of the load, and the two anode side of our diodes go to the other side of the load, and we're going to hook up our ground here. Now the way I have these, the way I have the orientation makes it easy just to hook up the transformer also. I'm going to hook up one side of the transformer there, and then the other side of, come on, the other side of the transformer. Oops, I didn't hook that up. Is going to go there. All right, that is the orientation that you want. That is our bridge rectifier. That's the circuit for the bridge rectifier. So let's go look at what that looks like waveform wise. Okay, I'm going to get rid of that. Let's go over, and that's not going to let me till I run it, but let's put a probe right here on our output, and we'll start with that just like we did before. When I run it, all right, here's our 0 point, our 0 axis, and there we're at about, oh, we're less than 11. But let's go down and change it so we again can see the whole thing. We know we're going to be about 12 volts peak to peak, so let's go minus 12.5, and then let's go 12.5 on the other side, on the maximum. So we are from 12.5 to minus 12.5, and you can see our waveform. Now you look at that and you go, well, that's just a full-size waveform. It's Brian. I'm just going to say you're absolutely correct, because this is pretty much doing the same thing that the full wave rectifier does, but it gives us more stability in this waveform. We can control this a little bit better, and it's a little bit more robust. So from here on out, and the power supplies that we make, and the one that you're going to make in class, sorry about that, that you make in class, is going to be using the bridge rectifier. Nice thing about these bridge rectifiers, this is, you can just use 4 diodes, or you can buy a little package that has all 4 diodes in it and just a bunch of pins. And we'll see that hopefully when we get back to class. Now, a couple things we have to take into account here. Well, let me do this first. Let me put another probe on the input so you can see that also. Okay. You see something a little bit different here, which is totally expected. What we want to concentrate though on is this green one. Okay. So when our waveform flows through this whole thing, right? Remember, we know how it flows through the diode. So if we have our positive component here, all right, we get to this point, we know we can't go that way, we have to go this way. All right, then we come back through here, we go through our load back to the negative side of our transformer. When we go the opposite way, we go here, well, we can't go that way, we have to go this way, through our load, and then back to the positive side of our transformer. So let me get this out of here because that's just going to confuse us. That might be a program simulation issue. The other thing that we have to take note here of is we're at about 10.5 volts, 10.6 roughly. And usually we only have a 0.7 volt drop, but we have to keep in mind that as we go through this bridge, there's one diode, there's two diodes that we are now going through. So we're going to have not a 0.7 volt drop, but we're going to have a 1.4 volt drop, which you can see 10.55, which is about 10.6, which is a 1.4 volt drop. So that completely makes sense. Now, why is this important? We've talked about taking into consideration when you have voltage drops across diodes, is this the voltage that you want? If we took this diode right now, for instance, if we were building a 12 volt power supply, well, after our rectified signal, we don't even have 12 volts. We only have a little over 10, about 10 and a half. There's no way we're going to get 12 volts. So we would either have to, well, what we'd have to do is change the ratio of our transformer to up this a little bit to give us at least above 12 volts. And we could do that fairly easy by lowering the ratio. So that is our 12 volt, I'm sorry, that is our bridge rectifier, not our 12 volt, but our bridge rectifier. You can see the differences. The two main differences, obviously, well, the one similarity is it looks just like a full wave, which it is, but the big difference is we have a 1.4 drop, 1.4 volt drop from what we really are expecting at this point right here. All right, so what we are going to do now, and what you will see in the next day or two, we're going to take this circuit right here and we're going to start adding on to it. Remember, our power supply, we start with 120 volts, and somewhere down the line, excuse me, we want a DC output. So maybe we do a 9 volt, I'm not sure what it is right now, but we're going to add some more components and we're going to start using this one right here. So at this point, you should have a good indication or a good understanding of the half wave, the full wave, and the bridge rectifier.